Greetings. I thought I'd better fill you in that this is a Gerald Harris Productions video. You may not duplicate this video. You may not duplicate it and sell it on eBay for over $1 million. It's the property of mine. Look at that cool symbolism. J antiderivative H. God, that is so cool. But let me move to the next slide and show you what we got going on today. What I'll do is if I'm there, I'll field any quick questions over the book assignment. If not, hang on to it, then I'll get them from you next time. I'm not real worried about that. I need to cover with you finally what's called the fundamental theorem of calculus. Doesn't that sound easy? And then I kind of got two things going for you today. I got a worksheet over what I cover with you today, and I wanted to slip in a math review assignment just to keep giving you extra practice on all of those antiderivatives. And then I'll do the same next time. I'll cover area between two curves, but then I'll come back with another review assignment. The more the better. So look at your class notes right there. I will try to click right along with these, so hopefully I won't get going too fast. But here's what I'd like to do on number one. I would like to graph the line y equal 1/3 x. It's as simple as it sounds. I'm going to start here at 0. I'm going to go up 1 and over 3 for my slope, up 1 and over 3 again, up 1 and over 3 again, and then I'm going to draw that line. Here's what I'd like to do. I would like to shade it in now using the vertical lines x equals 0, x equal 9, and the x-axis. Everything that we do today will be bounded by the x-axis. So I'm going to shade in from x equals 0 to x equal 9. So I would like to find the area of this triangle. Since that's a geometric figure that we know how to find the area of, that'll be pretty dang easy. The area of this will be 1/2 the base times the height. So the area of this is 1/2. It looks like my base here is 9 units long, and it looks like my height here is 3 units high. Well, 1/2 of 9 times 3 sounds like 13.5. So technically the area is 13.5 square units. Once again, we're not really worried about the units part of it. You'll see why here later as we go. So that's all there is to the first one. On your second one, I would like to do the same thing. I would like to graph the line y equal 2/3 x plus 2. So I'll start here at 2. I'll do the slope of up 2 and over 3. Up 2 and over 3, up 2 and over 3, so that here's the line that I'm working with. Well, what I'd like for you to do is shade it in, bounded by the vertical line x equal 3, the vertical line x equal 9, and the x-axis. So here goes x equal 3 right there, x equal 9 is right there, and right there. So what I'm going to ask you to find is the area of this here trapezoid. And since it's a trapezoid, I know that the area is 1/2 of the height times the sum of the bases. And then remember, the bases are the two parallel sides, so these must be my bases. So here goes, just looking at the numbers I got 1/2. It looks like the height of this is 1, 2, 3, 4, 5, 6. And then it looks like the sum of the bases, looks like this base right here looks like 1, 2, 3, 4 units. I could have also plugged in 3 into this equation. And then if I come over here and count this, it looks like I'm going to go up 8 units. I could have also plugged in a 9 right there. 2/3 of 9 is 6. 6 plus 2 is 8. So it looks like now I get 3 times 12. So the area of that trapezoid is 36. So far so easy. No calculus yet. And then here's my last one. Before I start the calculus part of it, of course. I would like to graph the curve y equal the square root of x. So I'm just going to pick some numbers that I know. I know that the square root of 0 is 0. So I'm going to graph that point. I know the square root of 1 is 1. I know that the square root of 4 is 2. And the next number I'm going to mess with is 9. The square root of 9 is 3. So here's this curve right there. What I'd like to do is estimate, this one's going to be a little harder, I'd like to estimate the area from the vertical line x equals 0 to x equals 9. So here's this area that I'd like to estimate. So take just a second, graph that, and then you come up with your estimate on that. And you can't be wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16-ish. If you got a better number, more power to you. But that one was a little tougher because it had some curvature in there. There's what we've done so far. Those resembled your 18 through 22 on your book assignment, where you just had to sketch the figure, use your geometry skills to figure out the area of it. Now come over to this notation. These are the exact 3 problems that we just did. I'm going to show you how to work through them, and then we'll see if our answers match up. Remember, the answer on the first one was 13.5. That answer is 13.5. Remember, this answer was 36, and this answer 16, 17, 18, whatever you come up with. But here goes. You've seen this part before, guys, but you haven't seen it with numbers on here. When you see it with numbers on there, that's called the definite antiderivative, the definite integral. Your steps are going to be this. I still need to find the antiderivative of this by any method that we need. That means simplify first, use u substitution second, look for e's, look for natural logs, whatever it takes. But here goes. I'm going to find this antiderivative. So I'm going to add 1 to the exponent. I'm going to multiply by 1/2, so I get 1/6. I'm not going to put the plus c, and you'll see why here in just a second. But now I'm going to do this. I'm going to put a straight line there, a bar, and I'm going to evaluate this antiderivative from 0 to 9. The little number on bottom, the big number on top. Now when I do this, here's what I need to do. I need to take 1/6 times 9 squared. I need to plug 9 into there. Minus 1/6 times 0 squared. So I need to evaluate it. Whatever my antiderivative is, I need to evaluate it for x equals 9, and then x equals 0. Well, when I do this, I'm going to get 81/6 minus 0. So my answer is 81/6, which if you run that through your calculator, it's also 13.5. That's what we got a while ago. Here's the next one. This is that trapezoid that we did a while ago that had an area of 36. Here's your steps. I need to find this antiderivative. So I'm going to add 1 to the exponent, multiply by 1/2, so I'm left with 1/3, plus 2x, the antiderivative of 2, and I need to evaluate that from 3 to 9. So your next step is you're going to run 9 through this, so you're going to find f of 9 minus f of 3. It's always a minus. The reason I don't need the plus c on here is I'd have a plus c here and a minus c here after I distributed, and my c's cancel out. So here's what I'm going to do now. I need to run 9 through there, and I need to see these two numbers. I'll show you why here in a second. I'm going to go 1/3 times 9 squared plus 2 times 9 minus bracket 1/3 times 3 squared plus 2 times 3. And when I run those through, this part right here, when I ran it through my calculator, I got 45. When I ran this through my calculator, I got 9. It tells me that the area is 36, just like we got a while ago. So here's what this is saying. The area under the curve on x equals 3 to x equals 9 of the function 2/3 x plus 2 is 36 units. So it gives me the exact value. So when I do it to this square root function, we estimated 16 a while ago, or whatever you estimated, we'll see what the exact value is. So I'm going to think of this as the antiderivative from 0 to 9 of x to the 1/2 dx. Let me add 1 to the power, multiply by the reciprocal, and then I need to evaluate that from 0 to 9. So here's what I got now. I need to go 2/3 times 9 to the 3/2 minus 2/3 times 0 to the 3/2. If I run this through, the square root of 9 is 3. 3 times 3 to the 3rd is 27. 3 goes into 27. 9 times 2, this becomes 18 minus 0. So the exact area under that curve was 18 units. Hopefully you came closer than I did. I was off quite a bit. But those are going to be the steps. Let me take you to this next page and talk to you about the fundamental theorem of calculus. It just says this. It sounds so easy though. If f is non-negative and continuous on the closed interval a to b, it's got to be continuous, and I got to have endpoints. If I don't have endpoints, then I can't find the area of it. Then this part here says the area under the curve from x equal a to x equal b of the function is, after you find the antiderivative, put b in there, put a in there, subtract them, and you got your area. Clear as mud. Find our antiderivative, evaluate it at b, evaluate it at a, and subtract them. So, kind of make it a little bit harder. Here's your next one. I went ahead and just jumped right to it, didn't I? Here's your number 7, it looks like. Here's what I'd like to do. I'd like to sketch a graph of this just so that you can see what you're finding first. And then I went ahead and plotted some points. When I had E, when I used 1, I had a number up here. Looks like when I used 2, I had maybe 1.5. You could look at that on your calculator. But basically, the graph is going to look something like this. So here's what you're finding. You're finding the area from 1 to 3. You're finding this area of that white that I just covered in. So it doesn't look real big, but it looks like it's got a little area to it. But here's going to be the steps. Pretty soon you'll do this without the graph. I just wanted you to kind of see what you're finding. Here's what we're going to do now. Find the antiderivative of that. So here's what I'm hoping you're thinking. There's a single e in here, so that means my u is going to be 3 over x. That makes my du, I'm going to think of that as 3x to the negative 1. That makes my du negative 3 over x squared dx. So I need to see a negative 3 over x squared. I would if I put a negative 3 right there. So I need a negative 1/3 out there. So here's what I got for a second. I've got negative 1/3 antiderivative of, let me just sub in, I've got e to the u, that takes care of this part, and the du takes care of that part, the negative 3 over x squared. And we remember that the antiderivative of e to the u is itself. So here's what I've got. I've got negative 1/3 e to the 3 over x, and I need to evaluate that from, so a bar, a straight line, I need to evaluate that from 1 to 3. That's what I got so far. So here's what I got next. Let me plug in a 3, so I'm going to have negative 1/3 e to the 3 over 3 is 1, minus, it's always a minus, negative 1/3 e to the, let me plug in 1 now and get a 3. Well, this simplifies to be negative 1/3 e to the first plus 1/3 e cubed. If you run that through your calculator, you're going to get approximately 5.79. So I just found my antiderivative, just like we've been doing, and then I'm going to run my numbers through it. I'm going to show you something pretty cool with your calculator here in a second, but I don't want to give it away yet. I'll let the suspense kill you for a little bit. Here goes my next one. This would be your number 8 on your graph. What I'd like to do is sketch a rough graph of it, guys. So I cheated because I did everything ahead of time so I don't have to take forever on the video. But if I let x be 0, I get 0. If I let x be 1, I had 6 over 2, I get 3. When I let x be 2, I got something about 3.5. And then when I went the other way, I plotted some points, but graph it, look at your calculator, go to your table, get your points. But I got something that looks like this for the graph. What are you finding this time? You're finding the area from 0 to 4. So 0 to 1, 2, 3, 4. Here's what you're finding. And remember, everything is bounded by the x-axis today. So we're going to find this area right here. On your sheet that I'll give you here in a little bit, I'll have you sketch the graph, and you get to use your GC as much as you want. Graph it, plot your points, trace your points, whatever you like to do. But there's the area that you're going to find. Here comes the calculus part of it. I can't simplify, but I have a quantity this time. So that makes u equal 3x squared plus 1. That makes du 6x dx. So I need to see a 6x dx. And I do this time. So happy birthday, you don't have anything extra to do. So this becomes the antiderivative of u to the negative 1/2 du. Make sure, since this was in the denominator, that you moved it up and made it negative 1/2. Let me add 1, multiply by the reciprocal. And remember, guys, on these, when it's closed, when it's a definite integral, I don't need the plus c. So here goes. I now have 2 times the square root of 3x squared plus 1, and I need to evaluate that from 0 to 4. So I added 1, multiplied by the reciprocal. I had nothing out here. Now when I run 4 through here, I'm going to have 2 times 4 squared is 16, times 3 is 48, plus 1 is 49. The square root of 49 is 7. Minus 2 times, run 0 through here. 3 times 0 squared is 0, plus 1 is 1. So I got a 1 right there. So it looks like this area is 12. As you do these, guys, of course I need to see the antiderivative. And I need to see the number that you get when you run the upper bound through there. And I need to see the number that you get when you run the lower bound through there. I'll show you in just on this last example how come I make you do that. So I need to see that, and of course the answer. And then here comes my last one. But you got the steps, you just got to figure out what the antiderivative is. So here's our last one. Doesn't look very pretty, to be truthful. But what I did is on my calculator, I went ahead and graphed it. And then I traced a few points. And at 1, I had 4. At 2, I had about 5.5. So my graph of it looks something like this. There's another piece of the graph over here. But if you look at your interval, I'm going to go from 1 to 3. I don't need this over here, so I didn't even worry about it. But I'm going to find the area from x equal 1 to x equal 3, and bounded by the x-axis. So here's the area that you're finding. What I'm going to do with you the time after next, we start revolving this stuff around the x or y-axis, and we get really some cool looking three-dimensional figures that we'll find the volume of. But there's the area that I'm going to find. You can kind of estimate it, but here goes. I need to figure out how to find this antiderivative. Well, you got to decide if it's a u, if it simplifies, if it's an e, if it's a natural log. Since there's just an x in the bottom, I know I need to simplify first. So x cubed over x becomes x squared, and the 3 over x I'm going to leave as 3 over x, because I know that if x is to the first power in the denominator, that means something to me. So now let me find this antiderivative. So this antiderivative becomes 1/3 x cubed plus the antiderivative of 3 over x. I'm hoping that you recognized it already. I got an x to the first in the denominator. If you try to bring that up, you would get x to the -1. As soon as you add 1, you get 0. And then you got to multiply by the reciprocal of 0. Doesn't exist. So 3 natural log of x. And then I'm going to evaluate that from 1 to 3. Okay. So when you do this, I need to see the number you get when you run 3 through there. So I'm going to go ahead and go parenthesis 1/3 times 3 cubed plus 3 natural log of 3. There's what I'm going to get when I run 3 through there, minus parenthesis 1/3 times 1 cubed plus 3 natural log of 1. If you remember, the natural log of 1 was 0 and you didn't want to write it, I'm fine with that. So when I ran this part through, I had 8 2/3. When I ran this part through, I had minus a negative, I went ahead and distributed, 1/3 minus 3 natural log of 1. But when I ran all this through, I wound up getting 8 2/3 plus 3 natural log of 3. So I had approximately 11.96. Just run that through, write down the number, run that through. I try to get fancy here so I didn't have to use my calculator. Run that number through, and then you'll get it. But there's the estimated area for that. So guys, our steps: find your antiderivative, run your upper bound through there, your big number, minus your lower bound. Hey, I'm going to show you one more thing real fast. I think you'll like this part, and you'll say, oh, that's why Mr. Harris is having me show those two numbers. I'm going to go ahead and launch my TI calculator real fast, I hope. Let me get my arrow and click calculator. If you would, graph that function that we just worked with. It should already be in your calculator from graphing it, but just in case, I'll give you a second, but graph it. Remember guys, put your parenthesis in there, and then do your x cubed plus 3, close your parenthesis, all of that over x. If you forget to do that, it's going to mess your graph up. You'll have an x cubed plus 3 over x. And then of course I went ahead and hit graph. So right here is there's what I got, and there's what I got. If you will then, go second calculate, and come down to number 7. See that antiderivative sign, antiderivative of f of x? Click on that real fast, and then hit enter. Now you'll see down here your lower limit and your upper limit. I want my lower limit to be 1, so 1, enter. And I want my upper limit to be 3, so 3, enter. Look what it's going to do for you guys. It's going to color in what you should see, and it's going to give you the answer. Happy birthday to you. So that's why I'm having you show me that first number and that other number. If you look at your number 8, if you wanted to check it real fast, if I cleared that out of here, I need to take the function 6x divided by the square root of 3x squared plus 1. And then once I graph that, there's the graph that we did just a second ago. I'd like to find the area under the curve from 0 to 4. So second calculate, number 7, from 0 to 4, enter. There it is. We had 12 when we did it by hand. My calculator says I'm right. So there's where we are. What I got you doing assignment-wise is you should have a worksheet that the sub can give you. So I've got you doing a worksheet. Let me get some ink real fast, where you will sketch the graph, and then do whatever it takes to get the antiderivative, but show me the first number that you run through. I don't like that. Show me the first number that you run through minus the second number that you run through. That's kind of my way of checking you, make sure you know what you're doing. And then go ahead and give me the total answer, and then feel free to check your answer. And then there's also, I want to say there's 9 problems on Math Excel. That's just some review. The more review I can get in you, the more success you'll have on your last test. Good luck on the assignment. Have a great day. And remember, this was a JH production. You don't get to copy it.